So if you want to understand about LSTM, so you can say this is basically cell state. Uh, this particular this particular line. So this particular line is basically cell state, right? So cell state, or you can say the memory cell. So if you, uh, the name sounds very typically difficult, but it is quite easy. Just be with me, I will make you understand. So this is basically cell state. So to understand this particular architecture, we have to segregate or divide this particular steps, or you can say architecture. So this particular part, this particular part, so it has three parts. This particular part is called forget layer. So I will tell you what each layer is. So this particular layer is forget layer, and let's understand what. And this particular layer, and this particular layer is input layer. So this is forget layer, this is input layer, and another layer is there, right? So this is basically, this is, so this is basically output layer. So there is three layers. So this is nothing but the output. So this is nothing but the output given in the upper cell. So that particular output is given to the next cell. So basically this is only one cell of LSTM. So this same LSTM will be attached to the next cell as well, right? So here also LSTM cell. Here also LSTM cell is there. So it is just that particular cell output will be given to this, and this particular memory, sorry, not memory output, this particular output will be given to this particular LSTM. So this type of number of LSTM is there, interconnected. Okay, so as you can understand, there are actually three basic three basic layer in the LSTM. So I will discuss about each layer. So you can understand, this is forget layer, this is input layer, and this is output layer, right? So, and this is nothing but the cell state that I have told you, cell state, and this is nothing but the output coming from the previous layer. T minus 1, you can say the previous thing, right? Before timestamp. So T means current timestamp. So recent word will be provided through this, and whatever the output coming from the previous layer, it is passed through this, and whatever the cell state coming from the previous cell, it will pass through this, right? So T minus 1, you can say the previous cell output, right? The previous cell output will be passed through this and this. So each layer I have told you, about each layer I have told you. So let's go through each layer. Okay, so the first thing I want to tell you guys, the memory cell. Like I have told you about the cell state, right? So this is nothing but the cell state. The upper line is nothing but cell state, right? So cell state, or you can say the memory cell. So what it does basically, it is doing the pointwise operation here. So cross means pointwise multiplication, right? And addition. This is the addition. Okay, so this is addition operation here. So what it is responsible for? This particular line that I have showed you. So if you go through this particular, so I am talking about. So I'm talking about this line, memory cell means I'm talking about this line. Okay, so I'm talking about this particular line. So if you go through this particular thing, memory cell. So if you go through this particular memory cell that I have showed you in the architecture. So what is responsible? So basically it is responsible for remembering and forgetting things based on the context of input. that I've showed you one example, right? So it has to remember paratha, it has to remember what, remember paratha and paratha and pasta, cheese to predict certain cuisine. So it has to remember paratha. At the same time, it has to forget paratha and save pasta and cheese to predict another thing, right? Another cuisine. So this cell basically responsible. So this particular cell, right? So this particular cell state is basically responsible for remembering and forgetting thing based on the context of input. And by this gate structure, LSTM does have the ability to remove and add information in cell state. So by this particular gate structure, you can say LSTM makes the things possible or gives the ability to remove which is not necessary. Suppose paratha is already saved in the memory. Suppose for next cuisine prediction, paratha is not necessary, so it has to remove. So how it is going to remove, I'm going to tell you. So it has to remove and add information to cell state. Adding means, suppose another useful information comes in, it has to remove the previous information and add some new information. So the cell state actually makes this possible. So how it is making possible, let's understand. So I told you this is the multiplication operation, this is the addition operation. So here in the layer, so what happens, um, as the information comes, like suppose the previous cell state has this particular information, right? 1 2 3, suppose I'm just taking example. And this particular output, this particular output is what, this particular output is coming from sigmoid activation function or sigmoid function, right? So if you guys know, the sigmoid function output is what, converts to 0 and 1. Suppose LSTM, like according to the vector reference, this is nothing but what we are providing. This is nothing but we are providing the current timestamp word. Suppose I have showed you in that example, Sam, paratha, eats, all the things that eats timestamp word will be projected in this particular what, this particular input area. So after that it will be passed to the sigmoid function. So what is the sigmoid function output? So sigmoid function output would be 0 and 1, right? So 0 and 1 would be the sigmoid function output. So it will be multiplied here, right? So output coming from the sigmoid function and input coming from the previous cell state. Supposedly this is the previous cell state, and this is the output coming from the sigmoid function. Suppose it uh, suppose it wants to erase some of the information. So whenever it wants to erase some information, it can provide 0, right? Close to 0. Sigmoid function will give close to 0 as the vector number. So if you multiply to this particular third vector will be deleted, third value will be deleted from the vector, right? So this is particularly a way to delete or forget some information. So we'll understand about this particular forget layer. So this is basically memory cell, like how memory cell work and what is the need of this particular memory cell. Okay, so next would be the forget gate. So what is the forget gate? So this is nothing but the forget gate that I have showed you in the architecture. If you go through the architecture, what I have told you. So what I have told you actually. So forget gate means we are taking this particular area as forget gate, right? So I'm taking this particular part and trying to make you guys understand so that it will be very much easy to get everything in the architecture. So this is basically forget gate part. So what we are doing in forget gate, so this is the first layer of this LSTM network. So this is nothing but ht minus is what, st minus is what, like whatever the output coming from the previous cell, previous LSTM cell, right? If there is no if there is no output coming from the previous layer, as we are initializing, So it can be a zero vector, right? So, and each in each time term what will be, we will be passed through here, right? So after this particular concatenation, this thing and each time term what will be concatenated. So after the concatenated, it will pass through this particular sigmoid function, and whatever the previous cell state will be coming through this and will add. So I have told you before only the memory cell, the same thing is going on here. Previous cell state value will be coming here, and the concatenated of this particular two value will pass to the sigmoid function, and whatever the sigmoid function will give output, that multiplication operation will be conducted in the cell state. So you can see this particular what this particular function value. So this, if you can concentrate, so this is nothing but the just linear function, right? This is a weight, and this is nothing but, you can say, any output, right? Any output, you can x plus some bias, right? So this is kind of a linear function. Y is equal to mx plus c, you can see. So this particular information we are passing through the sigmoid function. So let's understand what the value of like where the w come from, right? So it is nothing but when we are passing any word means nothing but the converted vectors, right? So if machine doesn't understand the word, so we have to convert to the vectors. So whatever vector we are passing through one weight as well. In deep learning, if you know the guys concept, so you can understand. So each input we are passing with an weight. So this weight will be multiplied with this, and will add some bias of this particular equation. So this particular previous output and this particular word timestamp word will be passed, right, with some weight. So we're multiplying weight in the both the factors, and we're adding some bias, and we're passing to the sigmoid function. So if you know like what basically forget gets to, we can read out this. So forget layer decides what info to throw away from the cell state. So I have showed you in the example, like it first stored paratha in the long-term memory, right? Paratha, it stored paratha. So when the pasta and cheese word comes, it terminates paratha. Like it forgets paratha, right? So in order to forget something important, we have to use this particular forget get layer, right? So how it is forgetting? So whatever information we don't want, this particular value will be close to 0. Suppose in the sigmoid function that will be output 1 1 0. So whichever close to 0, that information will be null, or it will forget this particular information. You can remember as this particular way. So when the new subject comes, forgets the previous one and remembers the latest important thing that I have showed you. So forgets the previous one and remembers the pasta, which is the latest important thing to predict next cuisine. So if the context changes, it may forget the information, but it will not forget everything. So if the context change, so if the context actually changes, so so you can see the paratha is there. So another important context is pasta. So the context is changed. So as the context is changed, so it will try to forget the information, right? So yes, so this is what basic of forget get. So let's go through the next layer. So what is the next layer? Next layer is input get layer. So we understood this is nothing but memory cell. So memory cell or cell state we understood. Then we understood about forget get. So after this forget get, what we have? The input layer. So what is input layer that I have told you guys? So input layer, if you go through the architecture, so input layer is this one. So if you go through this, so this is particular the input layer. So if you go through this, uh, this is actually input layer. This particular layer is input layer. So we discuss about this forget layer, right? We discuss about this. So we'll discuss about this particular input layer. Okay, so let's go through it. So if you can see this particular input layer that I showed you in the architecture, what it does, it like what new info we are going to store, adding the info to the memory set. So I've told you the paratha word is already there, right? Paratha word is already there. We are just storing the new word, what? Pasta and cheese. So we are storing pasta. So if you are storing pasta here, so this particular pasta is new information. So the new information is stored in this particular region or the input layer. So how it will work? So new information, whatever new information come, it do the addition operation. The memory cell, as it is doing the what multiplication operation, here it is doing the addition operation. So how it is doing it, it has two parts. If you notice, it has two parts. One is this, one is this one, tan h. So for segment part, which value we actually will update. So which value will update? So which value will update? So what information actually we want to forget, right? So this paratha is a word that we need to forget. It has to change. So this particular value will be, this particular segment function will give what? 0. So whenever it will give to 0, it will give 0. So we want to forget this particular word. So what new information we want to add? So pasta. We want to forget this paratha and we want to remember add pasta. So how we are going to add pasta? So the new candidate added to this particular state. So this particular state, it will add, it will go through this, the tan s, what the tan s will give. Tan s will give what? So -1 to -1 to what? -1 to +1. So this is the output of tan h function, -1 to +1. So whatever the information is 0, it will just delete it, and whatever the new information, it will just give you the enhanced value. So the new information will be added in the cell state here, right? So it will forget the paratha and new information as pasta and g, it will add in this particular layer. Combine these two and create an update to the state. So it is doing an updation of in this particular layer. Example, we replace to the new one. So as I told you in the example, so what example? Let me go through this example once more so that it will be clear. So what was the example I have told you? Sam eats. So what was the example I have told you? Sam eats paratha. So first paratha, it will the memory in the long term memory. The paratha will be stored so that it will predict Indian. So when the next important word will come, so next important is what? Pasta and cheese. So it has to forget paratha, or else in this particular cuisine it will also predict what? Indian, because the paratha is the Indian cuisine, but it has to forget paratha and remember pasta and cheese, right? Remember pasta and cheese to predict what? To predict Italian cuisine. So this thing actually I want to tell you. You can go through again this particular structure that I have built, so you can easily understand. So we understood about input layer. So let's go through the next layer. So what is the next layer? So next layer, what we are doing is we are just updating the old state. So let's go through how we are doing in the how we are updating the old state of the cell state. So how to do it? So in this particular cell state, what we are going to do? Cell state is nothing but the upper layer that I have told you. This particular multiplication operation and addition operation we have done in the input layer. This is nothing but the forget layer. So how this uh, input coming from the forget layer and input coming from the what input layer is affecting the cell state. So let's see. We have to concentrate this one. So this time to update the old cell state sheet 1. So we have to update this particular whatever the output coming from the previous cell state. We have to update this into the new cell state. So new cell state what? CT is the new cell state. So how we are going to update? Let's see. So previous steps we have already decided what to do. Now we just need to do it. So we have already discussed like what input coming to this particular forget layer and what input coming from this particular input layer we have already discussed. So we have to just update this. So how we are going to update? So this particular function that we have already discussed in the forget layer. So this particular function output into what? Input into the previous cell output. Addition of what? As we are doing addition here. So addition of what? Addition of what? It is like whatever the input coming after the sigma function. If you go through again the input layer, you can understand it and this particular tan function output ct will be multiplied, and we are doing the what? We are doing addition operation here. So whatever input coming from this and from this, right, we just have to add this thing. So ct will be updated like this only. If you concentrate on this particular function, you can easily understand. So ct minus 1 is the old state that is coming from this particular previous cell. Okay, so what it does basically, ct minus 1 ft. So what it does basically, forgetting things we decide to forget earlier. So whatever like it needs to forget, it will forget in this particular formula, in this particular state, this particular multiplication, it will forget. And and whatever this function, like what this multiplication is doing, so new candidate value, so where we drop info about old subject and add new one. So the example I told you, the in like adding the pasta. So adding the pasta is is done by this formula, pasta and cheese. So adding pasta and cheese is done in this particular formula, and forgetting about what? Forgetting about paratha. Forgetting about paratha is being done in this particular formula, right? So this both formula is nothing but the current cell update or current cell state, you can say. So if you go through this particular multiplication, how the inputs coming from previous layer, you can easily understand what it is going on. So it's a clear picture. If you go through this, you can easily understand. This is nothing but the output layer. So what happens in the output layer? So as you can see, let's see the architecture. So we have understood about this particular forget layer. We understood about this forget layer. Then we understood about this particular input layer, right? Okay, let's delete it. So input layer is this much, right? So understood about this input layer. This is forget layer. This is forget layer. This is input layer, and this is our output layer. Now we will discuss about this particular output layer. So we understood a forget layer, input layer, and this particular cell state. Now we'll just last layer is output layer. We'll just understand this particular thing, how it will work. Okay. So what happens in the output layer? So whatever info is in the memory cell passed to TANET. So just previous layer that we have discussed about updating the cell state. So whatever the output coming from the cell state, so whatever the output coming from the cell state, we are just passed through the TANH because we need the output information, right? So after remembering or forgetting any information, that particular like storage, memory storage, we have to pass through the TANH. So it will go by this way and it will come in this particular direction. Just remember the direction. And again, so whatever this particular previous output is st minus 1 and the current timestamp input. So this particular input is nothing but what? All the words in the sentence like Sam, eats, paratha. So each word will be passed through this particular timestamp. So okay, so here as well as that we have already seen. So in each layer we have only doing the same thing about concatenating these two both and passing to the sigmoid layer, and whatever the irrelevant information will be neglected and useful information will be stored as 111, right? So this particular output of sigmoid function will be given to this as O2. And what about the cell state? What about the CT? CT is nothing but the cell state that we have discussed in the previous layer. Cell state will be going down, pass through the tannage. So this cell state after passing through tannage, it will come to this particular point-wise operation, and whatever this particular multiplication happens with previous output state and the current time word will be multiplied or concatenated, then pass to the sigmoid function, and it will come to this particular pointwise operation. And here the multiplication will happen. So whatever the multiplication will happen, it will pass to the output as the next cell as st. So let's see how this particular equation works. So OT nothing but this particular output, right? So it will be concatenated here. So st minus 1, the previous output, and the current timestamp word will be I have already told you. So whenever you are passing any vector current timestamp word, it has some weight with it. So you have to this particular it will be multiplied with weight, and this particular multiplied with weight, and this both are concatenated. So these both are concatenated with addition of some bias. If you know the deep learning concept, how the neural network architecture works, so this thing will be very easy for this thing will be very easy for you guys. So then it will pass through the what sigmoid function. So what you can identify by this particular equation. And what is st? St means whatever OT will go to this particular point wise operation, we have calculated, and multiplication happens with whatever cell state. Cell state is now nothing but CT that we have calculated in the previous layer. Right? Previous layer means while we have updated the memory cell. So whatever the CT or whatever the memory state will be provided here, and it will pass to the tannage. Right? So this output will be provided like this. It is very easy. If you can concentrate on this particular diagram, you can easily understand. So this particular value actually what retrieve only important context from this pointwise information which fed in the next cell. So whatever the important information, how we can guess the important information, because it is stored in the cell state. We have updated the important information in cell state. So cell state has important information. So as we are just increasing, we are not neglecting cell state because we have not passed to the sigmoid function. If you are passing the sigmoid function, it will convert it to 0 and 1. As you are passing to the tannage, so the cell state information will be stored, right? So only the important information will be passed to the next next cell. The output will be based on our cell state but in filtered version. So you can see this particular output. So this is nothing but the output. So this particular output will be based on our cell state. So based on our cell state means CT, as this particular information is provided through this, right? So this particular output provided this, and this output is coming from this. So all are concatenated here with a point-wise operation. Then we got our output. So it is in a filtered version. So this is nothing but the basic structure of structure of particular LSTM. It is very easy once you go through this particular example, like how the example works, or how this particular important value stored in the memory cell. then it is be very easy to understand the architecture. If you want to predict this particular thing, this particular sentence in RNN, uh, it will be difficult, or the output would be wrong in many cases if you use RNN in this particular sentence. So it is useful to use LSTM where we need long-term dependency, right? So we need long-term dependency, but in RNN we just previous timestamp input only we remember. Like for second word we only remember the SAM. For third word we only remember whatever the output input given to the previous layer. So it's we only remember the previous information. We don't remember uh, previous to previous or long term important information, right? So this is how it will be useful. So thank you guys, thanks for listening.